Some questions you may be asked is, what are the zeros of a function? If you are given the graph of a function, you just look for the x-intercepts of the function. If the problem asks you to use a graphing utility, you would use the graphing utility to graph the function and then either approximate the zeros by looking at the graph or using one of the tools from the graphing utility to find the exact or approximate value for the zeros of the function. However, some of the questions, they may ask you to find the zeros of the function algebraically. So to find the zeros of a function, basically we want to know when f of x is equal to 0. So we set f of x equal to 0, and then we solve the equation for whatever the applicable variable is. For polynomial type functions, the way you find your zeros is you factor the polynomial. There are two different ways that I could factor this. Well, I have told you the first way, typically you want to try to bring out the greatest common factor. So in this case, I'd get x squared times 9x squared minus 25. And this is a memorized difference of squares pattern. So I get x squared, square root of the first, square root of the last, and then square root of the first minus square root of the last. And all these factors are equal to 0. And so if I want to know what my zeros are, I set each factor equal to 0 and solve. So my zeros are at, when x squared equals 0, x is 0. When 3x plus 5 equals 0, I get negative 5/3 for x. And when 3x minus 5 is 0, I get a positive 5/3 for x. Mentioned there were two ways to factor this. If you look at the first part, you should recognize that that is already a difference of squares pattern, where x squared is the square root of x to the fourth. So my first step could have been the square root of the first was 3x squared minus 5x, and then 3x squared plus 5x. And then factor out the greatest common factor out of each one of these, and that would have given me x times 3x minus 5. Pull out the x here, and 3x plus 5. And notice I have x equal to 0 at both of these places, and I end up with the other zeros from my remaining factors. So there are two ways to have factored this one initially. Factoring a cubic that has 4 terms, usually you're going to be able to factor it by putting parentheses around the first 2 terms, parentheses around the last 2 terms, and factoring the greatest common factor out of each set. Greatest common factor out of the first set is x squared. The greatest common factor out of the second set is negative 9. If there's a negative number in the first position of the second set, I always pull it out. So what I do is I'll write down my first factor, which would be x squared minus 9. And this is going to equal 0. And then I do the division, and I'm going to check my work. X cubed divided by x squared is x. Negative 4x squared divided by x squared is minus 4. And I'll check the work. Negative 9x divided by negative 9 is x. 36 divided by negative 9 is negative 4, so that checks. This still factors. That gives me x plus 3 times x minus 3. And these are zeros when x is equal to negative 3, 3, and 4. The last example I want to do is a rational function where I have a polynomial in the numerator and a polynomial in the denominator. Again, I want to know when this fraction or rational function is equal to 0. Well, you know that a fraction is equal to 0 when the numerator is equal to 0. So only thing I need to check is when is the numerator equal to 0. Well, x is 0 when x is 0. So my 0 is at 0. Once you find the zeros from the numerator, you want to make sure it's not going to cause a division by 0 problem. Because if you end up dividing by 0, that number is not in the domain of the function, so it can't be a 0. So I'm just going to do a quick check, putting 0 in for x. 0 squared is 0 times 9 is 0. Minus 4 is negative 4. So 0 actually does give me a value in the denominator, so 0 is a 0 of that function.